Wow. All right. It's an exciting day for space weather, not just because there's a CME about to strike Earth early in the day tomorrow, but because there is another one on the way, and this one is pretty major. It's quite directly headed toward Earth. We could see as high as a KP8 major geomagnetic storm from this one. We'll tell you all about it and more here at the Smash News Network, least busted name in news. That is a 24-hour video featuring ionized helium and ionized iron from the SDO. That huge filament there, you can see right in the center of the solar disk, and whoops, part of that filament is on its way to Earth. So exciting stuff going on. We can expect that to arrive sometime late in the day on the 19th, early in the day on the 20th of September, just before the equinox. Here's a little closer view of that filament eruption. Now, we've been naming filaments after living people on the channel, and when we have extremely promising filaments, we name them after extremely promising people sometimes. That one was named after Tamitha Skov, space weather woman as she's known. So if you haven't checked out her channel, check out her channel. She's recently won an award for her space weather coverage. She is pretty good at her job. So that is some sweet imagery indeed. By the way, we do have a new sunspot that just rose in the northeast, and a huge prominence showing up over there as well. A brief view of the equatorial portion of the closest star. The most active sunspot is the one north of the Earth scale there, which did feature a couple of M-class flares in the past 24 hours. Yowzers. And there's also a huge prominence down there in the southwest. That was one massive filament eruption. And here's a close-up of the Eugene Bagashov solar prominence, a type of filament that's hanging off of the limb from Earth's perspective. So how you like them apples? That's some pretty exciting stuff, right? Dag. By the way, today's video is brought to you in part by the Smash team. And this video is dedicated to the Smash team, as we might not be making these videos anymore had it not been for the Smash team helping to support our operations. So please consider doing the same, becoming a member of the Smash team. There's a bronze level, a silver level, and a gold level. The best value is the gold annual paid-up subscription. Once again, thanks to the Smash team for supporting the Smash News Network, least busted name in news. It's just the most comprehensive daily space weather content you'll find in the known universe. Extremely accurate forecasting when it comes to what the sun's doing, what the Earth's doing, and what's going on in between. Thanks to our new YouTube subscribers as well. Don't forget to press the like button. If you're new to the channel, don't forget to press the subscribe button. Do yourself a favor and get the world's most comprehensive daily space weather and most detailed imagery of the closest star you'll find in the known universe right here at the Smash News Network, least busted name in news. Here is yesterday plus today in SDO intensitygram, and we'll see a decline in sunspots despite that new group rising in the northeast, as we've had a bunch of sunspots setting in the northwest. Most likely place for a large flare remains this sunspot, as it does have the kind of magnetic fields, beta gamma delta class magnetic fields, that you could expect to produce large solar flare activity. Next, we're going to stop looking at space for a brief moment here and do a brief rundown of what's going on planet Earth in terms of volcanic activity. Abico is producing a 10,000-foot plume of volcanic ash at the flight level 100 over Paramushir Island. Mount Mayan, unknown volcanic ash plume there. Please don't pole vault the caldera. Semeru exploding, flight level 140 over East Java, Indonesia. Dakono exploding, flight level 070 over Halmahera, Indonesia. It's a 7,000-foot ash plume. 42,000-foot ash plume from Shishaldin. That is the forerunner. Major eruption there at Shishaldin in the Aleutian Islands there, producing a 42,000-foot plume of volcanic ash, flight level 420. Popocatépetl exploding in central Mexico, flight level 250. Fuego in Guatemala, flight level 170. 17,000-foot ash plume as Fuego explodes. Nevado del Ruiz exploding in Colombia, flight level 210. No volcanic ash recently observed from Sangay in Ecuador. However, Revenador exploding, flight level 140. Flight level 270 in Peru over Sabancaya, as Sabancaya explodes and produces a 27,000 foot ash plume, 24,000 foot ash plume over Ubinas. It is also exploding. It's a flight level 240. Yowzers. Next, seismic activity. No major quakes over the past 24 hours. We'll call out quakes over a 5 or greater magnitude. There's a 5.1 at the Kermadec Islands there, north of New Zealand. That was at 13:02 Universal Time yesterday afternoon. After that, quite a long time there until we saw another 5 or greater magnitude earthquake, a 5.7 at Chile at 18:07. That's 18:07 Universal Time yesterday evening. Indonesia then saw a 5.0. Only a few minutes later, about 9 minutes later, that 5.0 striking on the other side of the Pacific Ocean. And then another lull in 5+ magnitude quakes until a 5.0 strikes Tonga at 23:06 Universal Time yesterday evening. Then at 2:01, a 5.0 strikes. That was this morning on the 16th of September, a 5.0 in the Kermadec Islands. So quite a bit of activity there north of New Zealand. Remember, folks, any earthquake can be a foreshock. So we could be seeing foreshock activity there, just so you are aware of that. And let's get back to space weather. It's been rather exciting. So we were streaming the GOES 16 SUVI, as we're known to do on the channel. And here is the eruption of the Tamitha-Skov filament, going to become the Tamitha-Skov geomagnetic storm sometime late in the day on the 19th, most likely. So there's the filament on its way out, and it's been taking its time actually on its way out there. It's taken a few hours for it to propagate out of the sun's corona. Advance that a little further. You can see a bunch of limb darkening there. A large portion of that sunspot is headed directly toward Earth. I mean, not sunspot, a large portion of that filament is headed directly towards Earth. So yeah, it's coming. And it's exciting. Here is SDO 304 angstroms. That is another 24-hour video. You can also see a Hyder flare. That Hyder flare is this area right here where a portion of that filament collapses back down. You can see this brightening right around here. That is called a Hyder flare, Hyder. We've also got 171 plus 131 angstroms. Those wavelengths are good at showing the magnetic field lines as well as solar flare activity. All right, so back to space weather stats here. What do we have? Let's see what's going on. The 10.7 centimeter radio flux has dipped once again, now down to 139 solar flux units, I think it is. Anyway, that's the 1 year graph. The black line is the 10.7 centimeter radio flux. The red line is the sunspot number. Those two data sets are proportional to each other. In other words, they follow each other. They're great indicators of the solar cycle progression. Space Weather Enthusiast dashboard here, forecasting some geomagnetic storms early in the day tomorrow on the 17th. That is from a coronal mass ejection. Again, a big impact is on the way on the 19th. Here are the past 4 hours of Earth's magnetic moment from space. And we do have geomagnetically calm conditions here at the moment. That's our Geospace Magnetosphere movie. It depicts magnetohydrodynamic pressure, the units of which are nanopascals. So that's the last 4 hours of Earth's magnetic moment from space. Here are the last 4 hours of Earth's magnetic moment from the ground level. The units here are nanotesla magnetic flux density. And when we do have geomagnetic storms, this is a great way to determine where you're likely to see the aurora. Now, that ground magnetic perturbations map does also include a close-up of North America, and it shows the polar view as well if you want to view either of those. However, another great way to figure out where you might be likely to see the aurora, if you're in North America at least, is the geoelectric field map. So when we do have geomagnetic storm conditions, you can scroll down at the Space Weather Prediction Center, and you will find... So right here in the products and data, if you scroll down, you will find this model right here, the geoelectric field model. It shows induction into the power grid, as that induction does happen instantaneously. So that's one of the ways you can monitor the likelihood of being able to see the aurora in your location. It's an actual measurement of the amount of voltage being induced into the power grid. And it does vary based on the substrate. That's why you see that bright area over around the East Coast, as the minerals in the crust do affect the conductivity of Earth. So check out the geoelectric field map if you want to figure out where to see the aurora in your location. We could see aurora at mid-latitudes early tomorrow morning. But especially coming on the 19th. Let's look at some more space weather stats here. The KP index currently at 1. A geomagnetically calm situation that's not going to continue to last, as there is some big stuff in the forecast. Looking at the solar wind here, we've got about 4.5 protons per cubic centimeter for the solar wind density. Solar wind speed here, 423 kilometers per second. Pretty unremarkable there. GOES magnetometers here are pretty calm as well. Some pretty smooth curves there from the GOES magnetometers. You can expect to see some seriously spiky patterns in the next 4 days on those, as there is plasma, quite a lot of it, headed this way. Next, it's our top view ecliptic plane field plot. And Earth is remaining here in a south pole current sheet. A little bit of magnetic indecision actually happening. Check it out. You've got this little bit of north pole current sheet here. And for the most part, Earth will remain in a south pole current sheet. So that's just the polarity of the solar plasma there, folks. It does provide some predictive value, actually. And yeah, south pole current sheet expected to persist here for several days. Keep in mind the magnetic environment can change rapidly with basically no warning. Here's our line of sight field plot, the solar B field depicted here in blue. The polar fields depicted in green and red. And now to coronal holes. So we've got both north and south pole oriented coronal Here's hole in the Earth-facing portion of the solar disk. And the ones in the southern hemisphere, those are north. The ones in the northern hemisphere are south. And let's take a look at those from the SDO. So here's 211 angstroms, the best wavelength to view coronal holes from SDO. So basically what we've got is we've got North Pole coronal holes down here, South Pole coronal holes up here. That is the past 24 hours in SDO 211 angstroms, one of the many species of ionized iron observed by the Solar Dynamics Observatory. Great view of that filament eruption as well. Next to sunspots. Again, we still do have a high likelihood of large solar flares, mainly from this area right here, sunspot 3429, I believe it is. 3429 or 3434. Anyway, the next sunspot will be named, I don't know, 3442, I think it is. Anyway, there has been one new sunspot that just rose. So far, we only see one polarity umbra there. It is so far only an alpha-class sunspot. And here's an equatorial zoom in SDO intensity gram. Again, that sunspot above the Earth scale, it is certainly capable of producing additional flare activity. Don't be surprised to see an M or even an X-class flare coming from that sunspot group. And today we'll also show magnetogram, since there has been some evolution of those magnetic fields and umbrae. Another 24-hour video from the SDO HMI instrument, viewing the photosphere there. Next, we've got energetic particles and solar flares. The proton flux, no spikes in the proton flux here, so oftentimes we see solar energetic particle events associated with major filament eruptions. So far, no relativistic particles there, no solar energetic SEP particle events associated with that Tamitha-Skov filament eruption. However, a series of M-class flares have occurred in the past 24 hours. The largest one was the most recent. That was about a M3.3 class solar flare. And let's take a look at it, shall we? We've got some great views here once again from the Solar Dynamics Observatory. Another 24-hour video. Here's 94 angstroms. And we do have a rising possibility of large flares there on the northeastern limb as well, as we do see some activity there. I suspect that sunspot is at least a beta gamma delta class sunspot, not just an alpha class sunspot. In other words, there are likely more umbrae to rise based on the amount of activity we're seeing from that. Here's a little closer view of that active sunspot. You should see 3 M-class flares. Pretty decent succession there. And we'll show this in a few more wavelengths as well. Here's 335 angstroms, another species of ionized iron. Different number of electrons in its outer shells. And of course, depicting a different temperature. These are all part of the extreme ultraviolet, the EUV portion of light, ultraviolet light. So higher frequency than visible to the naked eye, also not visible from the ground level. Here's 304 angstroms ionized helium. An absolutely classic wavelength there from SDO. You can see that Hyder flare, you can see the filament eruption. Getting up close and personal there with El Sol, aka Helios. And before we get to that, let's take a look at what's going on overhead. So we're going to cover coronal mass ejections here in just a moment. First, a star chart. If you're looking at the dusk sky, you might see Mars and the Moon there trailing the Sun. If you're looking at the pre-dawn sky, you might see Venus and Mercury rising ahead of the Sun. And just a quick FYI, thanks to our viewer, Adam K., citing the fact that Comet Nishimura reaches its closest approach, its perihelion, its closest approach to the Sun, tomorrow on September 17th. So it will be kind of hard to view because it's so close to the Sun in the sky. You got to have a low horizon, low light pollution, and a clear sky. So it'll be in the evening skies there. Again, reaching its perihelion sometime on September 17th. There's a great view of the green comet. It is green. I know that image looks like it's blue. And there is a diagram of its path here from earthsky.org. some conjecture about whether it spawned a meteor shower. And there is its path. And make sure you let us know in the comments if it's going to brighten, if it's going to perhaps break up, who knows. So kind of right between the Earth and Sun here now, appearing in the evening sky. And then it's going to stay somewhat in line with the Sun there for a few days. Continuing along, here's your solar system forecast. Again, Nishimura is somewhere right in here. And here's your 7-day forecast for heavenly bodies. We hope you enjoyed New Moon. Here's where things will be on the 23rd of September. We will be in the season of autumn by that point for the Northern Hemisphere. And for your Southern Hemisphere viewers, you'll be in springtime by then. Check it out. Here's a sweet fireball over Iceland. That's the astronomy photo of the day. An enduring trail there. So it's a great example of why you ought to be out looking up and taking time-lapse photography. You might be able to catch great imagery like this of a fireball while you're out there looking for the aurora. So good times, exciting stuff when it comes to space weather. And let's move on to a brief cosmology story. So there's a story in SciTech Daily today about the brightest gamma ray burst, or well, the brightest optical / ultraviolet burst of light ever seen. Estimated to be 400 quadrillion times brighter than the sun. That's a lot of zeros, if you're wondering. And it's known as GRB 010122. No. 220101A. That gamma ray burster discovered by some Chinese astronomers. And it was discovered on New Year's Day, January 1st, 2022, hence the name GRB 220101A. You can also find an article on phys.org about it. It shows some other gamma ray bursts as well. Gamma ray bursts tend to last for a very short period of time and then are usually followed by extremely bright optical and ultraviolet and other radiation. Gamma ray bursts, the brightest one ever, at least in terms of its ultraviolet and visible light production. All right, let's get to coronal mass ejections. So here are yesterday's images. That's 91 frames from George Mason University. We don't think those are earthly directed. However, when we get to today's coronal mass ejections, it's a different story. So you can see a halo eruption there happening. That's the Tamitha-Skov solar filament headed this way. It looks like the densest portion of it will miss Earth to the south. However, it's very hard to tell how dense a CME is when it's headed directly toward the aperture. So there are certainly some dense portions of that. Again, we could see as high as a KP8 from this one sometime later in the day on the 19th. Dag! That is freaking sweet. So here's the latest from Soho Lasco C2 and C3. We're going to pause those right at the end as we don't have a full data set yet for this. So here you can see that halo starting to erupt from the C3. There's more data there from the C2. So great imagery there. And don't worry, we've got a lot more than that. So the C3 not great, but the C2, check it out. It does look like some relativistic particles are striking the C2 there. So a bunch of material headed quite directly toward the Earth. Good stuff. Good stuff when it comes to space weather. We'll also show stereo A before we show our custom coronagraphs. Feel free to pause the video on this frame if you're not familiar with the locations of the Parker Solar Probe, Bepi Colombo, the Solar Orbiter. Stereo A is depicted by this red circle here as it's slowly moving off to Earth's west. So there's the difference imagery on the right. Let's pause that. Again, you can see a halo, with the densest core indeed off to the south. So it's time for our custom coronagraphs, and they are totally sweet. There's a 24-hour video with SDO 193 angstrom, SOHO, LASCO, C2, and C3. And right at the end of that video, it's coming. Great view of that filament eruption as well as the CME on the coronagraphs. Here's an even closer view. Just a massive solar filament. And here's just 193 angstroms by itself. How you like them apples? By the way, that's a quote from Lance Armstrong. Yeah, it's true. All right, so let's take a look at filaments next. Filaments, filaments, filaments. By the way, this one we named after Scott McIntosh, as it is now the most likely filament to eject, since the Tamethyscove filament is headed this way. There's the El Teide, Spain ground-based solar observatory, and it was there, and now it's on its way here. You can also see that Hyder flare happening north of where the filament ejected from, as some of the material splashes back down toward the chromosphere. We'll also show the grayscale imagery. So, a great example of why we name filaments, folks. And before we get to our bonus features, let's take a look at the latest from the GOES 16 SUVI. And by the way, if you want to name filaments after living people, do it over on Twitter. Thanks to our new Twitter followers. One of these years, we might even reach 500. As if that's some kind of a milestone on Twitter. Anyway, here are the past couple of hours from the GOES 16 SUVI. You can see the tail end of that coronal mass ejection filament eruption. Also, quite a bit of instability happening over there on the eastern limb. So a prime example of how you can see quite a lot of exciting stuff going on, even when there is kind of a low sunspot number, frankly. So again, we're like over a year or so from solar maximum at least. So yeah, expect nothing but more activity like this to continue, and indeed more activity in the coming year. So we're in our bonus features segment. Charging hazards are non-existent, so satellites have got smooth sailing here at the moment. No energy electrons building up on or in them. The GOES electron flux here just in an operating range. You can expect this to crater early tomorrow morning when the first of 2 CME impacts strikes. That's the last 3 days from the GOES 16 and GOES 18's radiographic measurements. There's the 1-year graph to put all of that in context. Again, expecting a dip. Let's see what NOAA expects. NOAA is expecting an increase, so we'll have to see what happens there. The green boxes are the forecast. The yellow diamonds are the observation. We'll also show the layer of the atmosphere where it's measured. And a quick note, folks. Some people seem to think that solar plasma makes it all the way down to the ground level. That couldn't be farther from the case. So, there are multiple layers of atmosphere in between you and the sun. Up here, they're very diffuse, and then they get denser and denser until they're all the way down at the troposphere, where all of your weather occurs, where it's very dense. It's like 1 quadrillion times as dense at the troposphere level as it is at where it's measured in space at Lagrangian point 1. So Right now, the solar wind is about 4.5 protons per cubic centimeter. At the troposphere at sea level, it's like 4 quadrillion protons per cubic centimeter. And you've also got these temperature inversions in between space and Earth. So, look over here, you can see that the troposphere is warm at the ground level and cold at the upper level. The stratosphere is reversed. The stratosphere is kind of cold at the base and kind of warm at the top. The mesosphere is kind of warm at the base and kind of cool at the top, and then the thermosphere gets hotter and hotter and hotter, even though there's less and less and less material there, because it's really in space. That's actually getting heated up by the solar wind directly. So anyway, the point is, folks, solar plasma doesn't make it to the ground, ever. And if you're frightened that your silverware is going to be melted by space weather, then it's another reason to watch Tamitha Scove's channel. She can explain the physics better than me about why that is not a thing. So you need long runs of electric. You need long runs of metal in order to build up induction from space weather. Things like power grids, pipelines, and railways build up induction, not your silverware. Anyway, here is the F layer of the ionosphere. This data courtesy of the Australian Government Bureau of Meteorology. It's showing megahertz, millions of vibrations per second. And of course, the ionosphere grows. It gets taller as well as lower in the sky around the equator at noontime, as the sun is heating up that portion and ionizing a bunch of material in it, causing it to both be pressed down and pulled up all at the same time. It stretches it out. So that is the F layer of the ionosphere in megahertz. And if that's all Greek to you, don't worry, we'll show the anomalygram, which is a little bit more informative, perhaps. It shows anomaly in megahertz from the 30-day median. Interestingly enough, around the equinoxes is when we see the most geomagnetic storm type effects. So it has to do with a thing called the Russell-McLaren effect, which involves the acceleration of high-energy electrons in the outer Van Allen belt. Probably has to do with the orientation of Earth's magnetic field with respect to the incoming solar protons. It's more perpendicular. They're smashing into it at a more perpendicular angle around the equinox. Anyway, here's the latest image. There it is at 13:15 Universal Time for the ionogram and 13:15 Universal Time for the anomalygram. We also like to show total electron content. It's useful for Earthlings and for space weather enthusiasts, as it'll show Earthlings the most likely places for GPS errors, and it'll show space weather enthusiasts if anything funky is going on from the inner portion of the outer Van Allen belt all the way down to the ground level. So your GPS satellites at about 12,500 miles of altitude. Free electrons cause signal refraction. That's what you're seeing here. A forecast for the likely places for signal refraction. And things are looking pretty normal here. And by the way, if there was a major polar excursion going on, you would see electrons all out of place all the time. But you don't, because there is no spooky polar excursion going on. What's going on with Earth's magnetosphere is not remarkable on geologic time frames. In other words, it doesn't look like a pole flip or even a significant pole shift is occurring. It's why we show the data, one of the reasons we show the data daily on the channel. So here's the anomaly from the 10-day average over North America. And once again, we are seeing some high electron count anomalies there over southern Mexico and Central America. We showed it yesterday. Once again, it is back today. However, it has since shifted to low electron count anomalies depicted in blue. High electron count anomalies depicted in red. Again, that's the anomaly from the 10-day average for total electron content, literally a count of free electrons from about 12,500 miles of altitude down to your ground level. We'll close out the space weather portion of the video before we talk about hurricanes with the latest colorized magnetogram and latest intensitygram. So here's this new sunspot. Again, I suspect we're going to see some additional umbrae rising there of opposite polarity. There's what's going on now. So far, it's only an alpha-class sunspot. Again, I highly doubt that it is an alpha-class sunspot. Here is the most likely group to produce a large flare. It is still beta gamma delta class. And let's move on to meteorology. So, some accurate forecasting going on with that hurricane, as it has weakened exactly as we suggested it would. However, it is still producing some 40-foot waves. You might think those are the biggest waves in the world, but it's not the case, folks. The biggest waves in the world are actually down here south of Africa. Look at this insane low here in between Africa and Antarctica. We've got 45-foot waves down there. So that is an insanely gigantic low pressure zone there. And that is actually the world's stormiest seas, interestingly enough. So, of course, that system is weakening as it's crashing into land right now. It's also been beaten up by wind shear, and it's now over colder water, so it has basically no chance to increase its convection. It is breaking down quickly. Let's take a look at the rest of the air masses around planet Earth. There are the surface winds of the east. Here are the jet streams of the east. Shout out to our viewers from all around the planet. Don't forget to leave a comment if you're new to the channel, old to the channel, or moderately new or old to the channel. Jet streams of the central world depicted here. Surface winds depicted here. Surface winds of the west. This is, by the way, nullschool.net. Nullschool.net's fantastic, what is it called? Nullschool.net's wind map? I don't know what it's called. Anyway, there are the surface winds of the west, and here are the jet streams. The jet stream continuing to plaster Hurricane Lee. So let's take a look at this. Let's see how it's going to play out. So that low is directly south of the western point of Nova Scotia there. Let's advance this just one day. Here's where things will be on Sunday at 1 o'clock Eastern Time. That low will be moving a little bit to the west, like a north-northwest path according to the Euro model. GFS model has it in like the same place, so that's going to be pretty accurate there. There is going to be a lot of rain hanging out, of course. There's the Euro model. There's the GFS model for the next day. Let's take a look at some satellite imagery next. Here's a close-up of Hurricane Lee as it becomes shattered to bits. Here's the water vapor map. And again, it has entrained a bunch of dry massive air, which really did not help things. Sorry for all you disaster enthusiasts. It's not going to be that deadly, folks. Next, your weather.gov map. If your location is lit, head to weather.gov and click your county. There are too many counties there for us to cover. Maybe one day when we go full-time on YouTube, we will actually cover more weather. A bunch of warnings there over Texas. What's up with that? Let me press refresh. Severe thunderstorm watches there in central Texas. Weather.gov if you want to get your weather warnings. And here comes some forecasts. We're going to show some 72-hour GFS forecasts as we're wont to do. Strong system here forming over North Carolina in the coming days. So that's your 72-hour GFS pressure and precipitation forecast. Stop that. Here's your GFS 72-hour total accumulated precipitation forecast. And you can see a forecast of like 4 inches of rain there for portions of Canada. What is that? Brunswick, I think? Also some heavy rains there coming to the coast of North Carolina. Check it out. 5 inches of rain. Next, your 72-hour GFS mean sea level pressure and 10-meter wind forecast. Look at those winds just dying down promptly. Those winds just evaporating, following cold water and landfall. And last but not least, the jet stream forecast for the next 72 hours. The same model, the GFS. So we'll have a strengthening jet stream there forming right over my head, actually, as cold air once again injected down into Pennsylvania and beyond from Canada. Next, our lightning mapper. That's what's been going on. Again, heavy thunderstorms there moving south-southeast through Texas. And let's check our real-time lightning map here. Do we have any manifestations of Zeus or perhaps Thor in Texas? Looks like east of San Angelo we do. Quite a lot of strikes there. Perhaps an intensification happening. Anyway, next time you hear thunder, check it out, lightningmaps.org. Highly recommended. Once again, today's video was brought to you in part by the Smash Team at smashomash.com/Smash Team. It's not just Smash staff and I bringing you these videos at massive personal risk and expense and a massive operating loss. It's also the Smash Team. So you should be thanking the Smash Team if you aren't already a member. Thanks especially to the Gold Annual Paid Up subscribers. The biggest sponsors of the channel are our Gold Annual Paid Up subscribers. It's almost like getting 4 months of a gold membership for free, as it includes complimentary merch. Smashomash.com/Smash Team. Now, I'm not wearing the Smash Team merch today. I'm currently wearing the Mansa merch. Mansa. It's part of the channel's mission in the first place, which is to make America not suck again. Yeah. The best way to get out of a hole, folks, is to stop digging. So, Mansa, make America not suck again. Another one of the merch items you can pick up from the Redbubble shop linked below this video, as well as on the homepage. And let's close out with a plug to smashomash.com, the official homepage of the Smash News Network, least busted name in news. Smashomash.com. We built a massive web ring for people just like you. So visit our links, hit us up on social media, press the like button, press subscribe if you're new to the channel, press the share button especially if you aren't shadow banned on the internet, which you probably are. So congratulations for that. You aren't a stale, boring celebrity with boring ideas. And let's close out with U.S. Doppler radar. So there are those heavy bands of moisture. It's going to be a little rainy around New England. Anyway, we'll zoom out briefly here for the full 50-state view as it's raining in Alaska and probably snowing in parts of Alaska as well. How about a brief zoom of Texas? Some quite strong storms there moving toward Austin and Kylene. So there's the lower 48 view. Here is clouds and fog. And there is water vapor. There's once again a compression happening there, as we've got drier air down here, a relative low, and then an impulse from the north, driving cold air into warmer, moister air, creating huge pressure gradients, as you may have come to expect if you're familiar with the channel. It's called Understanding Atmospheric Physics, and you too can forecast your weather. You've got more than enough data at your fingertips. You must be accessing the internet as you're watching this video on it. Here's your recap. U.S. Doppler radar. It depicts vertical motion in the air column from ground-based Doppler radar systems. Space-based systems depicting 3.9 micrometer infrared radiation. It shows clouds and fog even though half of the country is dark. And here is water vapor. It shows all the water vapor, and most of the U.S. there is kind of dry. Anyway, an exciting time for space weather. Thanks for tuning into the Smash News Network, least busted name in news. We're frankly surprised that you found the channel. Don't forget to visit our links, press like, subscribe, share, etc. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.